Okay, so with this one, we can just well, actually, we'll go ahead and do the first part first. So you have your base to the power of y equals 1 over 100. So 10 to the power of y equals 1 over 100. Okay, now our 1 over 100, that's equal to 1 over 10 squared, which is equal to 10 to the power of negative 2. Okay, so that means 10 to the power of y is equal to 10 to the power of negative 2. So our bases are the same, so this would only be true if our y is equal to negative 2. Okay, and for C, if you have log of 10, remember that's just log base 10 of 10 equals y. Okay, so your base to the power of y equals your x position. So that means, let me clear that up a little bit. There we go. So you have 10 to the power of y equals 10. Okay. And with this one, you can just rewrite 10 is just 10 to the first power. So you have 10 to the power of y equals 10 to the first power. Your bases are the same, so it's only true when your exponents are equal. So y would equal 1. Or log base 10 would equal 1. All right. Any questions on any of those? All right. Leave that up for a few more seconds. So let's set that away. Let's say if we wanted to evaluate, let's say for problem A, log of negative 10. And for problem B, log of 1. Okay. So let's say, because remember, that has to be greater than 0, so we wouldn't be able to find that anyway. But let's say we just forgot about that rule and decided to try and find log of negative 10. So you have log of negative 10. We can just rewrite that as log base 10 of negative 10 equals y. Okay. So you have 10 to the power of y equals negative 10. Okay. So the reason that's undefined is we can do a lot with exponent of y, but there's no y we can plug in that would magically turn that into negative 10. If we plugged in 0, 10 to the power of 0 is 1. If we plugged in negative 1, that would be 1 over 10. If we plugged in positive 1, it would just be 10. So there's no number that can make 10 to the power of y become negative 10. So that's why it's undefined. Okay, so value, I might as well say no exponent y. I guess you could let value. No value of the exponent y. We'll make 10 to the y equals negative 10. Okay, so log of negative 10 is undefined. Really, log of any negative number is going to be undefined for that very reason. Okay, so for b, say log of 1, we can just rewrite that as log base 10 of 1 equals y. Okay, so we have our base to the power of y equals 1. So 10 to the power of y equals 1. And whenever you have that equal to 1, all you have to do is remember that anything to the power of 0 is going to equal 1. Okay, so we have 10 to the power of y, which equals 10 to the power of 0. Okay, your bases are the same, so that would only be equal if those match. So our y is equal to 0. Or log base 1 is equal to 0. I mean, log of 1 is equal to 0, not base 1. Technically, that's log base 10 of 1. All right, so any questions on that one? All right. Let me see. Okay, I'll leave that up for a little bit. All right. Now we're looking at our multiplication property. Of logarithms. Well, actually, they call it the product property, but same thing. Okay, so we have for all positive real numbers, and this kind we'll call it an uppercase M and an uppercase N. Those just represent any real number that's positive. And your base that doesn't equal 1, the log of base b of m times n is equal to log base b of m plus log base b of n. Okay, and for example, say if we wanted to write each as the sum of logarithms and simplify. Okay, so for problem A, we have log base 2 of 2 times 7. I know it's 14, but we'll just kind of practice with that one. Say for problem B, log of 100x. And for problem C, log base 5 of 125 times y times z. Okay, so for problem A, if we use the product property, actually let me put that in parentheses, it's more known as the product property than it is multiplication. Log base 2 of 2 times 7 is equal to log base 2 of 2 plus log base 2 of 7. Okay, so whatever product you have inside of here, you can just separate them with a plus sign. Okay. Now the thing is, this can actually be simplified a little bit more. This term here, what if we let log base 2 of 2 equals y? And that means 2 to the power of y equals 2. And remember, 2 is just 2 to the first power. Okay. So they have the same base, which means that your exponents will have to equal. That means your y is equal to 1. So this term here is just 1. So that's going to equal, I'll put it over here, 1 plus log base 2 of 7. You can't simplify that one because 2 to the power of y won't equal 7. So any questions on that one? Okay, so even after you separate them, sometimes you can still simplify them a little bit more. And draw a little line to just separate it a little bit. Okay, so for problem B, we have log of 100x. Since we don't have a base, we know that's going to become log base 10 of 100 times x. Since that's multiplied, that's going to equal log base 10 of 100 plus log base 10 of x. So all we did was get the product and separate it with a plus sign. Okay. Now this can be simplified. If we make log base 10 of 100 equal y. Okay. 10 to the power of y equals 100. Okay. So another 100 is 10 squared. So 10 to the power of y equals 10 squared. Our bases are the same, which means this is only true if our exponents are equal. So y is equal to 2. So that means this term is equal to 2. So that gives us our final answer. Move that over a little bit. Of 2 plus log base 10 of x. Thought I could get all 3 on this page. All right, any questions on that one? All right, now do C on the next page. Everyone's still writing. All right, looks like everyone's done. Okay, so C, which was log base 5 of 125 times y times z. The thing is, no matter how many factors you have, you just add a couple of extra plus signs. Okay, so that's just going to equal log base 5 of 125 plus log base 5 of y plus log base 5 of z. So if we had 125 wxyz, we would have 125 plus w plus log of x plus log y log. So you just keep adding plus signs. Okay. Now these two, can't really simplify them anymore, but this one you can. Okay, so let's say if we have log base 5 of 125 equal y. So that's 5 to the power of y equals 125. Okay, and put a little side note. We know that 125 is just 5 to the third power. 5 times 5 is 25. 25 times 5 is 125. Okay, so this becomes 5 to the power of y equals 5 to the third power. And our bases are the same, so the only way this can be true is if y is equal to 3. Okay, so this just becomes 3. Which gives us 3 plus log base 5 of y plus log base 5, about to put 10, of z. All right. So any questions on that one? Okay. Now we know whenever we have multiplication, we're going to separate them by adding. If we have division, we're going to separate them by subtraction. Anyone's still writing? All right. So what if we have our quotient property? Of logarithms. And again, let's say if we have our m and n be positive real numbers. Okay, so for all positive real numbers, m and n, and our base does not equal 1, log of base b of m divided by n is going to equal log base b of m minus log base b of n. Okay, so with multiplication, you separate them by adding. With division, you separate them by subtracting. So what if we wanted to simplify? Log base 4 of x divided by 64. Okay, so since we're dividing, our log base 4 of x over 64 will equal log base 4 of x minus log base 4 of 64. Okay. Now this one, pretty much set. Can't reduce this one. But this, you can. Okay, so if we let log base 4 of 64 equal y. Okay, so you have 4 to the power of y equals 64. Okay. 64, we can rewrite that as 4 to the third power. So 4 to the power of y equals 4 to the third power. Again, your bases are the same. That means your y has to equal 3. Okay. So this can be rewritten as log base 4 of x minus 3. Straightened up. All right. Any questions on that one? All right. So for our next example, we're going to combine the product and the quotient property. So some you can use more than one. So simplify log of xy divided by 10z. So x times y over 10 times z. Okay. So we have division. So we just go ahead and separate them by a minus sign. So log, and there's no base, so we might as well go ahead and put log base 10 of xy over 10z. Make that 1. There we go. Is equal to log base 10 of x times y minus log base 10 of 10 times z. Okay, so we separated this one using the quotient rule. Quotient property. For logarithms. Okay. But the thing is, once we applied the quotient property, that left us with two product properties. Okay. That means our log base 10 and actually this arrow don't need that in the way. Product property. For logarithms. Okay, so that means this is going to equal log base 10 of x times y is going to be log base 10 of x plus log base 10 of y. Let me move this over. This is going to stretch out a little bit. Log base 10 of x plus log base 10 of y. Clean that up just a little bit. Okay, so this just became this minus log base 10 of 10 times z becomes log base 10 of 10 plus log base 10 of z. Now there's a reason, well, you could have put parentheses if you wanted to, but there's a reason I put the brackets there. Because you had this term minus this term. So we converted this one term to these two, and this one term here was converted to these two, but it's still subtracting. Okay, so this is going to equal log base 10 of x plus log base 10 of y. If we distribute our minus log base 10 of 10 minus log base 10 of z. Okay. Now these three, once again, you can't really simplify those at all. But this one, you can. Okay, so we just let log base 10 of 10 equal y. 10 to the power of y equals 10. Or 10 to the first power. Our bases match, so we know that y has to equal 1. Okay, so this term here becomes 1. So that gives us log base 10 of x plus log base 10 of y. You can put minus log of z minus 1, or you can leave it the way it is. Minus 1 minus log base 10 of z. So you see kind of the whole way through you use that b to the power of y equals x conversion over and over. All right, so any questions on that one? All right. And our last property, oh, that's getting ready to shut off.